For this last video in this lesson, we need to discuss a potential issue that could pop up quite frequently when factoring higher degree polynomials and then solving higher degree polynomial equations. If you recall from the quadratics unit, we had a special case where we had perfect square trinomials, and if you recall, in a perfect square trinomial, we touched the x-axis exactly once, thus leaving us one real solution, even though we knew that the quadratic equation should give us two solutions. We called this situation a multiplicity. So if a root happens to occur more than once, we can say that it has multiplicity. In the case of the perfect square trinomial, the x minus 5 occurs twice in the given example here, and so we can say that 5 is a root with a multiplicity of 2. So we can see this happen quite a bit, especially when we have cubics and then 4th degree, 5th degree, 6th degree polynomials, however high you want to go up with that. So you can see in sample problem number 6, we're going to try to figure out how to solve this and find all of the real and imaginary solutions, and then decide which roots have given multiplicity. So you can see that the degree is 5, and we're just going to try to find all 5 of them. So I'm just going to walk through this one with you real quick. So the first thing I'm going to do is something that I did earlier. I'm going to use the equation to my advantage, and having that equal to 0 is good because it's still going to end up equaling to 0 when it's all said and done. So we have x to the 5th plus 4x to the 3rd equals 0. So you can see we're going to factor out a common x to the 3rd, so that's going to leave us an x squared plus 4 equals to 0. Now, x squared plus 4 is not factorable, and so we can go ahead and break this up with zero product property right now. So I'm going to get x to the 3rd equals 0, and I'm going to get x squared plus 4 equals 0. Now, you haven't done a lot of roots other than the square root, so this may look a little new to you, but this should be very comfortable as we go forward. If we have a x to the 3rd, we can eliminate that 3rd power with a 3rd root, and of course we have to do that to both sides. So that's going to leave us just x, and that's going to leave us equals to 0. Now, here's the thing. We know that x to the 3rd should have left us 3 solutions. So in this particular case, that's going to have a multiplicity of 3. So this solution has a multiplicity of 3. And then we can also solve the other one. And you can see here that we have 2 solutions here, and we have 3 solutions there because of the multiplicity. So we have all 5 solutions as a result. And so this is something that you're going to run into occasionally later in the unit when we start discussing graphing. We'll discuss when it crosses the x-axis versus just when it touches the x-axis, and how that has implications in regards to the multiplicity. Alright, that's a good little introduction to that concept that we'll be using a lot more later on.